Oh, what the heck is going on? Wow, that ruined my show opener. Sorry about that, chat. Sometimes that little chat window goes out of control. Wow, way to harsh my intro. Oh gosh, and now a train's coming, so I gotta wait. Wow, what a way to start the week, isn't it? Patience, focus, meditation. Here we go. Live from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about where the Furbies are coming from, and of course, taking listener questions about all things in this beautiful universe. We record every Thursday at 8 p.m. Eastern, and you can follow along or leave a voicemail at spaceradioshow.com. And today's Blue Shift, I'll be talking about Triangulum XL1. But first, the news. Hey, Space Cadets, welcome to Space Radio. I'm Paul Sutter, astrophysicist at Stony Brook University and the Flatiron Institute. And for the next half hour, your Agent to the Stars. We've got an exciting show for you today where we talk about all things space, astronomy, astrophysics, rocketry. If it's above the Earth's atmosphere, it's in this show's universe. This show lives on listener questions. We record every Thursday at 8 p.m. Eastern here at Spaceman Studios in New York City. So leave a voicemail at spaceradioshow.com to get yourself on the air. You can also follow along with our Space Cadets tuning in live from around the world, including but not limited to New Smyrna Beach, Christchurch, New Zealand, Treasure Coast, Florida. Is that what the pirates left? I don't know. Warsaw, Poland, Ashburton, New Zealand, Plattsburgh, New York, Washington, D.C., Chi-Town, shout out, Vancouver, B.C., Howell, New Jersey, Montevideo, Uruguay, Austin, planet Earth, and Malvern, PA. We're taking questions that the Space Cadets send. Not all of them, sometimes all of them. I think I managed to do that once. But you know what? We're going to do it anyway. Seriously, folks, I've only prepped 10 minutes to show material tops. So get those questions in. All right. And Seattle coming in late. Oh, wow. There you are. There's everyone. Hey, Space Cadets. Wow. How's your New Year's going? Are you sticking to your resolutions? 14 years ago, I made a resolution to not make any more resolutions, and I have stuck to it. That was the best resolution I ever made. If you have a better one, let me know. You guys want to talk about Furbies? This is hilarious. Nope, I'm the only one that thinks it's funny. Okay, fine. You know what? I don't care. It's amusing me, and this is my show, so I'm going to do it. And we're going to spend 4 minutes talking about Furbies, whether you like it or not. That's right. You can't stop it. How's my audio? I see Pavel is saying I need to move closer to the microphone. But I think it's all right. It's looking good. Feeling good. Which constellation has the least sticks in the figure? Canis Minor. I'll get in more detail. Sorry, got distracted. I'm getting distracted by the chat. I got focus on the news, focus on Furbies. Before I start taking questions, I wanted to share some interesting bits of news I caught recently, and I can't help. When Furbies are in the news, I just have to do it. I am compelled. My deep unconscious is driving me to talk about Furbies whenever they appear in the news. And they appear in the news about every 6 months. And they've... Oh, wait, sorry. I'm going to pause. I'm getting conflicting issues about the audio. Sorry, Greg. I'm going to adjust the gain here. All right, that's going to bring us up just a tad, and hopefully that sounds a little bit better. Some are saying good, but some are saying it's pretty low. So I'm going to redo the segment, and Greg is going to have to readjust my audio, which is not going to be fun for Greg, but who cares? He ain't here to complain, is he? Let me know if this audio sounds better. I just bumped up the levels just a tiny bit. Maybe I knocked it when I was setting up all my gear. Man, this is a rough show. We've got a long show ahead of us. Better get right. Don't stop messing with me, Space Cadets. Okay, it is. Use the Furby. Audio's good. Okay, thank you. I'm finally reading the comments. Let's just do this show, man. Before I start taking calls, I want to share some interesting bits of news I caught recently. And once again, Furbies are in the news. And when Furbies are in the news, I can't help but talk about it. There's a deep, unconscious driving force that forces me to talk about Furbies. And Furbies come around in the news every 6 months or so. And I just have to. And guess what? There's a Furby story. By the way, there's a conference. The American Astronomical Society meeting is happening right now out in Hawaii. Lucky ducks. They are, quote unquote, having very serious discussions about the nature of the universe and not at all sipping Mai Tais on the beach. I swear it. I've never done that. I've never gone to a AAS meeting and skipped a session or two. No, we're very serious astronomers. And anyway, so there's lots of astronomy news coming out this week because of the conference. And one of them is about Furbies. And of course, when I say Furbies, I mean FRBs, which are fast radio bursts. I don't know if the astronomers who came up with this name of fast radio bursts thought that they would eventually be called Furbies. I don't know if I'm the only human on the earth that calls them Furbies instead of FRBs, but I just can't help myself. FRBs, fast radio bursts. What are these? These are bursts of radio that happen very fast. Very descriptive name. They're just like whoop, like they happen in less than a second. They scan across a bunch of frequencies. So when we're observing with radio telescopes, we'll just get this flash of radio energy that are incredibly bright. I read one estimate that in a single fast radio burst, the amount of energy released is more than the sun will emit over 100 years. So that's a tremendous amount of energy compressed into a very, very small amount of time, scanning over a bunch of frequencies, and then it goes away. The vast majority of FRBs just happen once and never ever happen again. We've been seeing them for about 10, 15 years now, ever since really we got sensitive enough to be able to detect them. And every once in a while, there are repeating FRBs, which are even more mysterious. And the thing is, they don't seem to come from any one kind of galaxy. They don't seem to come from any one particular direction on the sky. In this latest Furby named, are you ready for this? FRB 180916.J0158 plus 65. Now that's a name for the history books. They were actually able to pinpoint the origins of this FRB, this Furby, and it came from a spiral galaxy not too unlike our own, a mere 500 million light years away, which is the closest Furby ever found. And this is the only Furby confirmed to come from a galaxy like our own. We've seen them in dwarf galaxies, we've seen them in giant galaxies. Now we're seeing them in a spiral galaxy like our own. All this does is add up to the mystery because it's hard to come up with an explanation for Furbies if they're coming from all sorts of different galaxies. If you say, oh, these are coming from galaxies that have a lot of star formation, so maybe it has something to do with the formation of stars. But then we find Furbies in galaxies that are hardly popping off stars at all. And you're like, oh, maybe they come from like dying stars, but then we get one from like a spiral galaxy like ours. It's just a mess. Obviously, it involves a lot of energy, which usually it means something is dying in the universe, something is going catastrophic, but what exactly, we are really having a hard time. So, as of today, barely into the new year, Furbies are still a mystery. Remember, you can leave a voicemail or follow along live. Just go to spaceradioshow.com for the links. That's the latest and greatest when it comes to space, but it's time to have a conversation. Nerdy rodent, it is not aliens. Do you hear me pounding the table? Not. You're doing it just to make me mad, and I know it. It is. Just stop. Just stop. Don't make me mad, all right? It had a rough start to the show, and finally in a groove now. Just don't. You know what you do? You push my buttons. You push my buttons, nerdy rodent. All right, we do have a voicemail that I'm going to start with, and then we'll head to all the awesome Space Cadet questions. Once again, thank you so much, Nancy Graziano, for wrangling the Space Cadets, for getting those questions on the back channel for me. You guys ready for this voicemail? It's a pretty fun one. Greg, are you ready? I hope so. We've got a voicemail ready to go. Hey, Greg, why don't you play that tape?
Hello, my name is Abdullah. I would like to know how can I start learning cosmology, because I don't know where to start, to be honest. So I would really love to know where to start, and also what books would be good to read and help me through my path. Thank you.
Oh, Abdullah, this is such a wonderful question. I'm glad you asked. I get this question a lot of either students or high school students or excuse me, or people that are just casually interested in astronomy. They've heard about it and they hear all sorts of cool stuff about cosmology, about astrophysics, astronomy, and they don't know where to start. My first suggestion always is to watch YouTube videos. No, that is never my first suggestion. My first suggestion is, like, if you're going to do this, why don't you go all the way? Like, if you're interested in cosmology, if you're interested in astronomy, if you're interested in astrophysics, why don't you go all the way and make this a hobby, which means signing up for a course. Why don't you look up your local community college, your local university, and see if you can audit a class? A lot of times, no joke, most universities have programs for senior citizens where senior citizens can audit classes for free. But I am not kidding. Look up the courses offered by the astronomy department or the physics department. Look at what's being offered the next semester. Email the professor. Just cold email and say, hey, I am not a student. I have no interest in pursuing a career in astronomy, but I'd really like to learn more. Is it okay if I just walked in and sat in on your class? That's it. That's it. Now, some professors may be uncomfortable with it. Most professors are probably not going to care at all. They're like, yeah, sure, whatever. Obviously, the university doesn't technically want you there unless you're paying the big bucks, but on the professor level, they like the idea that someone random is enjoying this and wants to show up voluntarily, unlike the majority of their classes that have to be there for an elective or for some mandatory class. So seriously, just email the professor, call up the professor, ask if you can audit the class and just sit in because you're curious, you'd like to learn, and then just sit in. Take the class, do the homework for yourself. A lot of universities, a lot of community colleges will offer some sort of intro to cosmology class, a cosmology course, and this was one of my most favorite classes to teach, a cosmology course not meant for professional astronomers. This is a cosmology course meant for people outside of physics or astronomy. So the math requirements are going to be a little bit lighter. It's going to be more discussion-based, more reading-based. Buy the textbook, whatever the professor probably wrote the textbook, for just buy that professor's textbook, read it, go along with it, participate in the discussions, like, and commit to that thing like once or twice a week, like turn it into a hobby. If you can't find a cosmology course, then I recommend doing the exact same strategy with an astronomy course, a basic astronomy course or a basic physics course. Because the things you will learn in an astronomy course or a physics course or both will allow you to go out and read popular books about cosmology or watch videos about cosmology, some of the higher level stuff, and you'll have a much better grounding. You'll have a much firmer understanding of the basics when it comes to these topics. So if someone says the word redshift, you're like, oh, wait, I took this astronomy class and I learned what redshift means. I know what this person is talking about. And so I don't have to have a big mental hurdle over this one jargon word. I can just move on and get to the point of whatever this person is talking about. So I really advocate for that. Like, learn it. If you want to learn something, learn it from the experts. Yes, some faculty, some professors are making YouTube videos and they do a really good job. There's things like Khan Academy, which is pretty cool. I suppose there's the book that I wrote, I don't know, Your Place in the Universe, Understanding Our Big Messy Existence, which serves as an amazing introduction to cosmology. But get it from the source. Get it from the people who are literally researching this. Get it from the people who are making this their day job. What better avenue is there to just learn it from those people? Even if they're not the perfect instructor or the most energetic presenter, you're getting it right there. So give it a shot. You know what? Just go all out, risk it all. Don't be scared. Don't be nervous. The students don't care. They might notice you the first day and after that, because I have had people audit my class who were adults who were obviously not college students. The college students noticed for a week, and then they realize that they're way too busy to worry about these kinds of things. And if I just say, yeah, there are people auditing this class, don't worry about it, they say, okay, yes, professor, we won't worry about it. So give it a shot. What have you got to lose? I'm Paul Sutter, and this is Space Radio Beside Your Dignity. This show is brought to you by you. Go to patreon.com/PM Sutter to learn how you can support the show, and I'll see you after the break. Larry, I believe Steven Weinberg does. Maybe I'll teach a class at Stony Brook. Maybe they'll let me. I love teaching classes. I love teaching college courses. All right, Arnetta, you watch the program How the Universe Works. You call yourself a Science Channel astronomer. I love it. I love doing How the Universe Works. It's airing. The next season has started airing, I believe, at Thursdays at 10 p.m. Eastern. Nice. All right. Let's see what kind of questions the Space Cadets are cooking up. I hope it's good ones. Oh, man, tons of questions. Cosmic, yeah, I wish. You need to stream a class. I need to give a class. Maybe I've got a chalkboard. Maybe I should just do a pretend lecture. Okay, you know what? I thought someone was going to make a comment about the long sleeve shirt under the t-shirt. Someone was going to comment that I look like Sheldon. I knew it. I saw it in my head. As soon as I picked these shirts out, I knew someone's going to say, oh, you looking like Sheldon. Thanks, Cosmic, for being so stereotypical. I was wearing this before Big Bang Theory. There are pictures. There's evidence. Meta-teach. What's a meta-teach? Does that mean I teach the teachers? I love it. All right. You guys ready for 9 minutes of nonstop Space Cadet awesomeness? I sure am. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. We've got so many more questions ready to go, but remember, you can join the conversation by leaving an online voicemail or by following the live streams. Check out spaceradioshow.com for all the links. And now, it's time to give some Space Cadets some love. And what do we got? Starting us off the bat, we've got Campbell Duncan on Twitch asking, how do we see the light of first scattering when the cosmos was soon filled with non-ionized hydrogen blocking the view? Thanks heaps. Well, what we see, to give everyone some background, the universe is big and it is expanding, which means in the past it was smaller. And at some point in the past, it was so small, so hot, and so dense, it was a plasma. It was a crazy hot soup of charged particles and radiation all bouncing around each other like crazy. But then the universe expanded and cooled, and it switched from being a hot plasma to a relatively chill neutral gas. And that process released a bunch of radiation. This radiation persists to the present day. We call it the cosmic microwave background. When it was released, when the universe was just 380,000 years old, it was literally white hot and had a temperature of a few thousand Kelvin. Nowadays, it has a temperature of 3 Kelvin and is all the way down in the microwaves, but it completely soaks the sky. This image, this light is something we call the surface of last scattering, because it's the last time this light bounced around all crazy and then got loose and was able to freely stream throughout the universe until it hits things like our eyeballs or our detectors. And so we call that the surface of least scattering. And we can see it because the entire universe was soaked in it. So what we see as the edge of our universe, what we see as this ancient fossil light, is from a patch of the universe that is now inaccessible to us, because that light was released, traveled to us, and in the meantime, the universe has expanded over the course of 13.8 billion years. And so now that patch of the universe that emitted that light is now unfathomably far away from us and expanding away from us so fast that we can never reach it. But the light is still here. It's like getting a postcard from a friend who moved to Europe and is never moving back, and you can't buy a plane ticket. So you can never visit them again, but you get that one last postcard. The cosmic microwave background, this light, this ancient light, was also generated right here in this patch of space that we call the solar system, that we call the Milky Way. It wasn't the solar system. It wasn't the Milky Way back then. It was just a hot patch of the universe. It too emitted light, and now this light is somewhere else. It is somebody else's cosmic microwave background, and we're the ones who are inaccessible to them. So we get to see this light because the universe cleared out. It went from foggy to transparent, and this light was just left to hang around and float around until it hit something, and some of that light is finally hitting our detectors. Next question, Cosmic. Can you show them how to calculate the Hubble Constant, please? They're still getting it wrong. Wow, yes, still in the news. Hubble Constant, this is the expansion rate of the universe as it is today. We've got no clue what's going on, folks. Some sets of measurements are calculating a Hubble constant that is relatively low, like 68 kilometers per second per megaparsec, if you're curious about the units. And some sets of measurements are making it seem higher. These measurements disagree. Are we getting the measurements wrong? Are we getting physics wrong? Are we getting the universe wrong? Are we getting all the above wrong? I tend to lean to we're getting the measurements wrong, but who knows? Only time will tell. Arnetta Davis on YouTube is asking, I'm hearing a lot about the discovery of the Radcliffe wave. Can you give an explanation of what it is and why it's important? This is another result coming out of the meeting, the American Astronomical Society, the AAS meeting out in Hawaii. As everyone is sipping Mai Tais on the beach, they occasionally mutter something scientific about something they're working on, and the press is right there to lap it up. And this is a really cool feature that we've discovered inside the Milky Way galaxy. There is I want you to imagine almost like a giant snake that's it's huge. It's thousands of light years long. And imagine the snake plunging in and out of the disk of the Milky Way like this. And if you're just listening to me on the radio or a podcast, I want you to imagine me waving my arm, because that's about what it's like. This is a feature of newly formed stars, of stars that have just hatched, that have just formed. Why it takes the feature of this wave and not like a bubble or a block or some other structure we still don't fully understand. Probably there was a region of our galaxy that started popping out stars, and there's all sorts of complicated, interesting gravitational interactions that twisted all these stars up into this interesting shape. It's given this name because I believe it was identified by researchers at the University of Radcliffe, if I remember right. And so hence the Radcliffe wave. And maybe that's the name of the next hit viral TikTok dance or not. I'm not exactly sure. Engineering on YouTube is asking which constellation has the least sticks in its figure. Whenever we see constellations, we play connect the dots with the stars. And I believe the most boring constellation in terms of really you're actually going to assign a name to that constellation is Canis Minor. Canis Minor is the little dog and consists of 2 stars connected by a straight line. Yeah. Someone just saw like 2 stars. You know, there's some ancient Greek or Persian, and next to it is Canis Major, the big dog with Sirius, the brightest star in the sky, and it looks pretty impressive and vaguely canine-like. And then next to it, they're like, oh, maybe they're like making the constellations, and then there are these 2 left over that didn't really belong anywhere else, and they're like, oh, shoot. Guys, we need a constellation. What do you got? What do you got? And someone's like, stick. And they're like, no, that's too obvious. We need to be creative. And they're like, how about a little dog? Fine. Okay, fine. And it's the only little dog in the sky. It's the only 2 stars in the sky that look like a little dog. Listen, I don't understand the origins of Canis Minor, but there it is. They were left over. The space cadets are agreeing with me. They're just left over. Like, oh yeah, we need a constellation here, don't we? Nancy Graziano on YouTube is asking, are FRBs directional in nature? Are Furbies directional in nature? If so, I think detecting one would be a stroke of luck. We don't know. We don't know if FRBs are like a spherical blast and it's just a matter of power and then we see it, or if it's something like a jet and the jet has to be lined up right in our faces to see. We suspect it is maybe a jet, which explains why they're so rare. Remember, we're scanning all sky all the time, every night, and we've only seen a few dozen Furbies in the past 10 or 12 years. So they are relatively rare. So they might be directional, but we don't know for sure. Dobby Dazzler on YouTube is asking, antimatter drive gets an astronaut to Alpha Centauri at, say, 10% the speed of light. Then come back with acceleration and deceleration. What sort of age difference will they get? At 10%, so you're talking about time dilation and the speed of light, and going close to the speed of light slows down clocks. At 10% the speed of light, it's basically nothing. I think even going to the nearest star and back at 10% the speed of light, I don't know the numbers off the top of my head, but I'd be surprised if it's more than a few minutes difference. You have to get really close to the speed of light for these time dilation, time slowing down things to really kick in. And unfortunately, we're almost out of time today on Space Radio. But before we go, it's time for the Blue Shift. Man, this show, 9 minutes just blew by, didn't it? Wow. Orion's dogs, yeah. Canis Major and Canis Minor. He's up there going, let's go, boys. Let's get that bull. Let's get Taurus. Oh, man. Out of questions, out of time. Whew. All right, let's do this Blue Shift. No cheese today, by the way, folks. Don't get excited for any cheese. Sorry, I just didn't get a chance to buy it. My bad. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift, my opportunity to get a little bit closer to you. And I want to give a huge shout out today to a space cadet that got a little bit closer to me, an artist by the name of Preston Sturgis. And you can find out more about Preston at psturgis.com. That's psturges.com. He's an artist. He does all sorts of cool stuff, including music and novels and also paintings. He sent me a painting. I'm not kidding. He sent me a painting. He's like, Paul, I like your work. I thought you might appreciate it. He sent me a painting of something he calls Triangulum XL1, number 41. And he included a lovely note. And it's absolutely breathtaking, the painting. Once I get it up and mounted, I will share a picture on social media. Once I find a good landing spot for it in Spaceman Studios. But I checked it out. It is absolutely stunning. And in the note, Preston says, hi, Paul. Here's Triangulum XL1, number 41. My protagonist looks off into the great immensity from the loneliest duty station ever. Keep up the wonderful work. All blessings to you, Preston. Once I get it up, I can't wait to show you because the painting is gorgeous. The painting evokes this sense. It really does. Because I looked at the painting before I read the note. It evokes this sense of loneliness, of enormity, of expanse, of smallness. The same kinds of beautiful mixtures of feelings I get when I look at a clear, dark sky. And anytime an artist is inspired by science, inspired by astronomy or any kind of science, my heart just like skips double time. I just love it. So thank you so much, Preston. I truly do appreciate it. I will get some pictures up on social media once I get it mounted. And if you're curious about more Preston's work, please go to psturges.com. That was really nice of him. I really appreciate it. And it's gorgeous work. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. Once again, I'm Paul Sutter, and this show is brought to you by you. Visit patreon.com/pmsutter to learn how you can contribute. Thanks to Greg Moebius for producing, Nancy Graziano for wrangling the Space Cadets, and all the fine crew at WCBE Radio for making this show possible. Catch the live stream every Thursday at 8 p.m. Eastern. Visit spaceradioshow.com for all the info and links. And of course, thanks again, Space Cadets, for listening. See you next week. And remember, science is for sharing. End of transmission. We did it. We did it. Love all you guys. Thank you for watching. I have to record a couple promos for Greg for the radio back WCBE back in Columbus. So let me get my timer up. These are going to be 30-second promos. So you guys get to see this. Remember when I would do this back in studio in Columbus? I'm Paul Sutter, host of Space Radio here on WCBE 90.5 FM. And this week, we're exploring the mysterious, wonderful world of Furbies in space. What does that mean? Well, I guess you're going to have to tune in at 2 o'clock on Saturdays to find out. Sorry, no, I'm not explaining it in the commercial. Nope, you have to listen to the show. All right, what's a general one? One I could do. Greg always loved it when I would just make up commercials for him on the spot. I'm Paul Sutter, host of Space Radio here on WCBE 90.5 FM. And did you know that if you were to go nearly the speed of light, my show would not take a half hour to listen to, but will be over in less than a fraction of a second? I don't know if that's a good thing or a bad thing, but why don't you give it a shot and tell me how it feels? Catch it Saturday at 2 p.m. There, that should make Greg happy. Greg, if you're not happy, then you're just gonna have to visit me and tell me yourself, because I miss you. All right, Space Cadets, see you next week.